Last stream, I was working on getting the terrain mesh generation ported across to the server. Today, I'm going to get started on the actual uh, pathfinding for mobs, so that the troll can start chasing the player around. I believe we're now live on both Twitch and YouTube, so welcome wherever you're joining from. Now, I have adjusted my microphone settings a little bit, so let me know if you have any issues with the audio volumes or the quality, but hopefully it's even sounding a bit better than it was in the last couple of streams. Okay, so I'm going to get started on the pathfinding. There's two steps that I'm planning on doing here. Where I want to get to is where mobs can pathfind over the terrain and avoid obstacles. So if there are cliff faces, hey Conrad, how's it going? Good to hear the sounds working. If there are cliff faces, they won't just kind of walk up them. Hopefully, they'll be able to avoid drops down big cliff faces, for example. And then they also need to be able to avoid partially dynamic obstacles. So things like trees, I consider to be partially dynamic. They're not part of the terrain. They are things that can appear and disappear as the game progresses. So I do want the mobs to be able to avoid those. But as a first step, I'm going to work just on the pathfinding. I should also point out that we left off the last stream with quite a few bugs in the terrain generation. They have been fixed, and I'll put out a kind of a 10 to 12 minute video, 10 to 15 minute video that kind of goes through the process I followed for fixing that. I'll release that sometime soon so that you guys can see what I actually did to fix it. But if I can just find my, what do we call it, writer. I'll get the client up just to show everyone where we're at. Somewhere in here we have Unity. Hey Griffith, welcome back. Currently just going over where we are at. I'm sorry, you guys probably don't want my drinking noises. Start up the server. And then the client should be able to connect. Hopefully I haven't broken anything since I fixed my bugs. So here we go. It's generating terrain just as it was before, except this is all coming from the server. So I fixed the bug that was causing the terrain hexagons to not connect up properly. That was an issue in the way that the corners, the X and Z, specifically the Z coordinates, were being generated on those hexagons, and that's been fixed now. I've also changed the server so that it sends through materials. So it can send through sand, it can send through grass. That is currently, as it was before, just being based on the height, but I can change that later. The troll is still behaving the way it was. If anyone saw my video from the weekend on getting the mob turning and attacking, you might have noticed he was looking a lot more fluid than this, and that was just because I turned up the tick frequency just for the recording of the video. What else have I done? Oh, I also changed the code for inserting entities into the world. So you guys have seen me putting in those big JSON blobs to insert the troll. I now have a new endpoint. Where is it? There's my, there we go. Yeah, here we go. I have a new endpoint on the entity controller, on the entity service, which allows me to insert prefabs. And I have just defined a troll prefab to have the agent information. So now I can just post to, I can do a post like this. Here's the last one I did. As opposed to entities prefab troll 0044, which is his coordinate, and that troll will get inserted at the at that coordinate. So that's another thing I've done since my last stream. So next, I do just want to go over the theory of pathfinding very, very briefly, because while I'm not working on obstacle avoidance yet, I do just want to get the troll walking over the terrain, and I don't have obstacles for them to avoid yet. I do want to make sure that I'm doing things in a way that's going to be consistent with avoiding obstacles. And while this particular article here, I quite like the Ray Wenderlich pages. This is very Unity specific, but the general approach is actually, this is probably a really bad example. Well, the high level approach is pretty close to what I'll be doing. And yes, I will be using A star, but I will not be using A star yet. I'll be using A star once we're doing obstacle avoidance. So the steps to pathfinding, I'll just increase this a bit so the images are a bit bigger. The first thing we need to do is generate a Nav Mesh. Now, a Nav Mesh is just a network of convex polygons. So I like to think of that as polygons without any kind of ini bits. So you can imagine if we had an ini bit just there, then that would not work. But you want to come up with these convex polygons, and they connect to each other through edges. Now, for anyone who's been watching the streams, you will, of course, recognize that that's similar to what we already have, which is this terrain is all convex polygons. So that's a good start. So without any processing, I could create a fairly detailed nav mesh. It's not as efficient as it could be if I used bigger polygons, but we'll get to all of that soon. It'll do for now. The second step is then to run a search algorithm. Griffith has mentioned A star, and that is a pretty good choice for pathfinding. I have seen suggestions that there are better choices for AI, in that sometimes A star will find where it's given a choice between arbitrary equivalent paths, it will often find very unrealistic looking paths. So it might find where you would prefer it to move diagonally between 2 points, it might sometimes take a slightly strange direction around that. And there are alternatives to that. I think one of them is called theta star, I think is one of the most commonly used. But I will be using A star. I don't think that I'll run into the issues. When I do A star, I'll explain why I don't think I'll run into those issues. But it's to do with how the heuristic is written, that I'll write it in a way that I don't think will get problems. It should always move diagonally. So what you do is you run a search algorithm that finds a series of polygons that you can pass through, which is the minimum distance to get from your origin to your destination. Once you have that series of polygons, you then need to have you need to convert that into a linear path. So as you pass, you can see here, as we pass from this polygon to this polygon, whether we do it on the left-hand side or the right-hand side or through the center, the AI agent needs to make a decision about how it's going to do that. And usually the class of algorithms is called string pulling. I think that there's a broader class of algorithms that can be used, but I'll be using a string pulling algorithm to do that. Now, because I don't need to worry about obstacles, I don't need to use A star. I'm going to be I can generate a list of polygons by saying, all right, if the troll is standing on a polygon over here and he wants to move to a polygon over here, I really just need to draw a straight line. I do need to know which polygons he's passing through because I need to make his height go up and down as he moves along that. And while there are simpler ways of doing that, I'm going to need to do that anyway once I do implement A star. And yeah, Not Matt W points out that he's just been working on some basic pathfinding with A star. It's by far the most common for this kind of this kind of pathfinding. Um, uh, yes, theta star is a thing. It sounds like we've got a couple of people in the that are familiar with A star. The key to A star can be done in a way that finds optimal paths, or it can be done in a way that it runs faster and finds not necessarily optimal paths. It's my understanding that if you set it up to find optimal paths, which you do by defining your heuristic in a particular way, um, it will not suffer the problems that people have with A star. It will always find an optimal solution, and that should be a diagonal path. I believe that is true. I could be wrong, in which case I'll have to move to theta star. But because we're just finding a straight line, and I just need to find the list of polygons that we're going through, I can actually just use a linear interpolation. Let's go and pull up my reference material, which is Red Blob Games. And yes, if man, the trolls, I don't know who's been, where people are at, but yeah, the troll does attack now. And he does a bit of damage. The timing is all off on the damage, but he attacks. He's got a cooldown, and yeah, all we need to do now is have him chase the player. Reference material. I just need to find. We're not after pathfinding. I could potentially use this pathfinding algorithm. So the proposal here is that you mark hexagons as obscured and other ones as travelable, and then you use A star to find your way around this. I may end up doing that as a first cut. Again, you can do a lot better because you can see there's a huge open area in here. This could be represented as a single node, which would speed up the A star search by a lot. And yeah, Griffith, the what you're referring to there, where you kind of do multiple layers, it's often referred to as hierarchical pathfinding. I have a bit of a background in spatial search, mostly for navigation, so vehicle navigation, pedestrian navigation, and it's quite common to use hierarchical searching in that. And yes, it's great for pre-computing the bits that aren't going to change, and then you can do the finer grained navigation at a lower level after that. What a lot of people do in games, as I understand it, is they do the A star on static data, and then they use their string pulling algorithm to pull out that finer detail. But another way of doing it is a second layer of searching within each room. But that's probably my preferred way. So I'm not going to do this search yet because I know we don't have any obstacles yet. So I'm just trying to find I know there's a piece of reference in here that is related to what I'm doing. Something to do with lines, rounding to nearest hex, pixel to hex. Things, reflection. All right, let's go back up to the index. Line drawing, this is going to be it. So I can't remember the author's name here. Someone Patel, Amit Patel, I think it is, the author of this site. He proposes this idea that to move from a square to some other square, all you need to do to find the hexagons it covers is linearly interpolate the line, the straight line from there to there, and then for each point, so this one, this one, this one, this one, you just map back to the you map back to the hex coordinate from these blue dots. I kind of can't. Can I get that to stick? No, I can't. So I can't really point with the mouse. I was about to try pointing with my finger, which wasn't going to work. But you get the idea. So we just find the distance in hex tiles, and then we place that many points along the line, map them back to hexagonal points, and then we should be able to get the list of hexagons that the troll needs to pass through to get from A to B. Then what I'll do is I will draw I'll define the list of edges that he needs to pass through. Most string pulling algorithms refer to those edges as portals because they become the portals between adjacent cells. Yes, Fun Nubicodes points out that pathfinding um, um, it takes more effort than it should, but the built-in libraries leave a lot to be desired. I find, well, I've never really used things like Unity's Nav Mesh in anger, but I always find it difficult to work out how to do things like putting actions into the search, into the path. Things like how do you get a mob to know that it can jump up a ledge, for example. I'm sure it's possible to do using Unity's Nav Mesh and AI code, but I always find it very unintuitive as to how to do that. So because I don't have any good libraries available to me, I'm sure they exist for TypeScript and Node.js, but I really, really, really need a stateless library. So I need a library that can go and generate some state, push it off into the database, and then come back and access that state later. I can't have in-memory state. So I had a bit of a look around, couldn't find any libraries that were going to meet my needs. So I'm definitely going to have to develop this myself. Yes, A star on a hex map for the voxels. Yeah, and so that is what what have we got? Pathfinding. That is what Amit Patel is suggesting here. But you can do better than that. You don't need to work on the voxels directly because some of them are just going to form big blobs here, and you can just treat those as a single node, as long as you define your weight appropriately in your A star. All right, into the implementation. What have we got here? I suppose the first question is where I'm going to implement this. Ideally, it would live off in its own service, but I'm going to cheat a little bit and implement it in the terrain service for now. We can just pull it out later. Have we got chunk route? Excellent. So I'm actually going to create a new route in here. I'll just copy and paste the chunks route, and I'll call it the path route. Get rid of most of this stuff, and I'll define path router, I call it. A bit inconsistent with my naming here, aren't I? Path router, and I'm just going to have a single route for now, which is going to be a post. And all this is going to do is generate a path. Get rid of all of these. Generate path. Path. I'll need to parse out some parameters here. This is going to be path. I'm going to send the path back. It's all just boilerplate. In here, I need to add the this new paths router. Perfect. I need a new controller. Call this one the path controller. And this just needs to export. Oh, hang on. const generate path. Oops, I don't know what that was. Export generate path. Back in here, it's going to let me import it. Path controller, is that the right name? Ah, no, I usually do this as a class. Okay. Path controller, he will have a function. Generate path. We're doing TypeScript, so I'll be explicit about these. Don't need to export that anymore. Okay. Okay. Restart the server in debug. I'll just make sure that that controller kind of works. It's not really doing much yet. So we should be able to do a post. Well, we shouldn't be able to do a get on paths. That's correct, but we should be able to post to it. There we go. That's, I believe, returned a 200. It's, yep, 200. Okay, perfect. So next thing I need is I need to work out what kind of, how this is going to work in here. So it needs to know its origin. It needs to know its destination. So let's do an options, pathfind options. For now, I'll just do an origin being a coordinate, and a destination being a coordinate as well. These are UV QRY coordinates, so hex coordinates. And then I'll just implement something in here. Yes, Griffith's comment there. I'm currently working on replicating server authoritative events versus client authoritative events. So this is something I need to put a lot of thought into. The client, obviously, in my case, I don't want authoritative for anything because other than what the player is actually pressing at any point in time. I want the server to be doubling up on all the processing and being authoritative for everything except for which keys are being pressed by any given player. But that's not the case at the moment. At the moment, I've got the player sending through their location, so a hacked client could generate events that would send them off to you could teleport at the moment in mine. Yeah, that's exactly my goal as well, Griffith. That's it takes some thinking, and you need to be able to handle, because the server and the client will get out of sync. That's it's kind of a given. It's not so bad if they're both written in Unity or something, because you know that they're going to be rounding floating point numbers and doing all of that the same. But they will drop packets. Things will happen. Things will get out of sync, and you need to think about how you'll bring the client and the server's view of the world back into sync. And when you'll do that, because you don't want to do it every time they get out of sync, because they might come back into sync You don't want things jittering around. Okay, so I'm going to generate a path. We need to go, I'm going to first of all just spit out a list of coordinates that it's going to run through. Let's get this across here. Let's get this one across here, just so that I have my reference material. And then I want the line drawing. So what does he actually return here? Amit Patel returns an array of coordinates, which is exactly what we want. Perfect. We take the cube distance. That's I think I have that function. Then they do a cube linear interpolation, which is just a linear interpolation of each of the 3 cubic coordinates. Round it to the nearest coordinate, and then put it into the array. I think this is really straightforward. Oh, what have I done here? I've resizing it has just moved everything around. Okay. So the first thing I need to do is convert into, because we've got chunk coordinates and coordinates within those chunks, I need to convert them into a consistent view of the world. So yes, fun Nuba codes, correct. You really don't want things jittering around, because even if things get out of sync, they might come back into sync, or the difference might be negligible. So you just don't care if the client is off by a few centimeters out of it when they're running across a field. Something I am planning on doing is when things do get out of sync, I want the client to be told they're out of sync, or to realize they're out of sync, and for it to gradually bring things back into sync. So the server will be the source of truth, but the client will allow itself to display the wrong thing as long as it's not too far out. So we're going to generate the path. We need the coordinates in a consistent coordinate system. Now, I'm going to cheat a little bit here, and I'm able to convert a coordinate to just an equivalent QR. Why is that not working? Origin dot, I'm pretty sure it's called .qr, which just flattens the entire world into one big coordinate system. So relative to the origin, what are our hexagonal coordinates without worrying about chunks? And so in here, oh, that needs to be options dot that. That looks better. So in here, we're going to go const origin axial is equal to that. Destination axial options dot origin dot destination qr. Okay, then let's just start by returning the distance, which is going to be origin. Do I have a distance function? Nope. I can do destination dot minus origin, and I think I've got a dot magnitude. I think that will give me the right answer. That crashed. Restart the services. Nope. What's going on here? Path route. Ah, yes. In here, I'll just pass through the request dot body. Won't do any valid. Oh, I do have to do validation on it. That's annoying. I could just change the type of that, but I might as well just get this code working. Const origin. No, let's go const options is going to be equal to find options. We need an origin, which needs a UV. Parsient dot body dot origin dot u. We'll do a v. What's wrong with that? Oh yeah, I need to use a constructor here. New trunk coordinate. There's the u. There's the v. That looks happier. We'll give it a QR. I'm about to have a similar problem to the fact that origin is meant to be a coordinate type. This will convert pretty easily. We need to give it a Q. We need to give it an R. Then this needs to be a coordinate. Taking that and that. There we go. Now I'm going to need to repeat all this code, so let's pull that out into a separate method. Get coordinate from param. Is it that button? Nope. That button. There we go. I like editors where you can just type in multiple places at once. Rec dot body dot origin. Destination. Get coordinate from param rec dot body dot destination. Okay. That looks kind of good. So now I need to come up with an actual payload here. Minus data. What is it going to look like? I might as well do this in IntelliJ. It's going to be a lot easier with syntax highlighting. Do JSON origin. Let's do it all in a single chunk for now. B Q. But we'll go from, let's go from the origin. This is one where a script would probably be really helpful. All right, let's do a really simple case. Let's say from the origin to the origin, does it generate a distance of 0? No, it crashes. That's not a good sign. I'm just going to turn down my tick rate as well. This so that we don't get quite as much spam. I'll just put that down to a tick every 100 seconds. That didn't do what I wanted. Why not? Oh, because I've got a client attached. That's where most of the spam's coming from. All right. Rerun that, and we get, it doesn't like request.body.origin. Oh, I know exactly what's going on here. This is just a problem with my command line. I need to tell this that this is JSON. There we go. Distance is 0. If I increase one of these parameters to say R1 and Q1, this I think is a distance of 2. There we go. Yep. Whereas 1 minus 1 should be, I think, a distance of 1. Yes. Don't worry if you don't understand why those distances were what they are. That's if you, it just comes from the way that the hex system works. Okay, so we've got the distance. Now it's time to generate the path, the coordinates that we're going to pass through. Const n is going to equal that. I think this is going to be +1, is it? No. If I'm going by 2, let me just pull up the source. What do they do? No, they don't do a +1. Good. Yeah, the 0 point forms an extra point, but that's okay. For I equal, oh, let's just do this as an array n.keys. That will just give me a nice range. Dot map. What's wrong with that? Oh, dot to array or something? All right, I'll just do this as a for loop. Um, let's see. Need to do a cube.round. So first of all, I need to generate a coordinate, which is just linearly interpolated between the origin and the destination coordinate. Okay, I'm going to come up with a round cube method here. Cube. It needs 3 parameters. We need the Q parameter, which is just the destination axial.q. There's just going to be lots of repetitive code, so let's just copy their lerp function. Go. We're just going to do a lerp from origin.q to destination.q by 1 over I. R and S, R and S. Now my axial constructor, I think, does a rounding already in it. Let me just check that constructor. Yes, so cube round, what it actually does is if you get, if you pass in non-integer Q and R values, it actually finds which of Q, R, and S has the biggest remainder, or is the furthest off from where it got rounded to, and it gets brought back in. It readjusts the Q and the R values to minimize the difference in everything. So I've already got that code for cube round. I don't need that. So I can actually just say a new axial coordinate. And the best part is I don't have to calculate the S because my axial coordinate sorts all that out. Okay. I then need to convert that into a coordinate because this is working on a big flat plane as if there are no chunks, but we care about chunks again. Oh, well, for the simple case, let's just say that we don't care about chunks for now. I'll just send back axial coordinates. We send back the path. Path.push axial. That doesn't look good. I'm sure people are laughing at me. This is going to be something dumb. Axial is a new axial coordinate. Oh, okay. The Q and the R value are null. Oh, lerp is not returning. No, it is returning. All right, breakpoint time. Origin axial dot q, destination axial dot q. Oh, 1 over 0. Yes, I'm meant to be looping from 1 to n plus 1, am I? What does the reference code do? The reference code... Well, this is wrong, right? Oh, 1 over n, not 1 over I. Sorry. 1 over n times I. Let's just pull that out as a t. IntelliJ knew that I wanted to call it t. That's pretty cool. Okay, trying it again. Don't want my breakpoint. It's just crashed something. Okay, this doesn't look right, does it? Origin to destination. Ah, yes, because again, I do want this to count. I don't care about the 0 point. I just care about the point after that. So in this case, where we are pathfinding from 0, 0 to 1, minus 1, it says just go 1, minus 1. If I instead say 1, 1, where we're going to get 2 points back, that is not what I was hoping for. I'm going to bring up this again, and up the top we've got the actual coordinate system. Right, so this is our Q value, this is our R value. So when we go to 1, 1, we are actually going to minus 1, 1, minus 1, 0. Oh, we're on the second one out. Where is 1, 1? Is this tile just here? Is where we're going to. So I expect it to be passing through either 1, 0 or 0, 1. But it's not. So let's go and have a look at what we are generating. I'll get that breakpoint in there, run the code. When I equals 1, t, what's t? T is a half. Perfect. In here, we're coming from, what's our Q value? We're coming from 0. We're coming to 1. Ah, I think I see the issue. By not passing through an S coordinate, I effectively bypass the rounding code because it goes and computes an S value consistent. Yeah, I've done a really bad job of explaining that, but I'm pretty sure that if I just explicitly pass in an S coordinate, I'm pretty sure this will just work. If I've done all of this properly. Number or null. Let's say if S is null, then calculate it. I think I can say undefined in here, can I? Will that fix that particular bug? No. S is undefined. Still unhappy. I think I have to set, do I have to set a default on this or something? Oh, yeah, okay. I need to pass it I think there's a way of doing an overloaded constructor in here. Bear with me one moment. No. Is it really going to make me specify that undefined? I don't want to specify the undefined. Right. TypeScript. Set default constructor argument. I thought I had already done that. I must have started typing that and then changed my mind. Okay, so if S is undefined, then we compute it. Otherwise, we use the S that's passed in and calculate and round it to the nearest coordinate. Back in here, this compiles. Segmentation fault. That's going to be the debugger crashing. Doesn't sound like a problem in my TypeScript, at least. Okay, still not working. Okay, t equals 0.5. So we're trying to find the point halfway along. We're coming from here to here. We're trying to find a point halfway along. Now, this is a pretty nasty case, of course, because the point halfway along is actually on the border between these two tiles, but I do expect it to work. It certainly shouldn't be returning this one over here. So the point that it's trying to generate is a point at 0.5, comma, 0.5, comma, and I presume this one's going to be a 1, -1, yep. So when we try to do the constructor, we step in here, Q is 0.5, that gets rounded to 0. No, 1, that gets rounded to 1. And now I've just crashed again. All right, I'll just go through this manually. 0.5 will round up to 1. This one will round up to 1. S will stay as -1. Q diff, because it got rounded, Q diff is equal to a half, R diff is equal to a half, and S diff is equal to 1. S diff is the biggest of these. All right. Let's go and look at, come back a couple here. There's the implementation guide where he has his actual rounding code. Hex round. Hex rounding. So, Amit Patel rounds the Q, rounds the R, and rounds the S. S is going to be equal to math.round S. And in fact, I believe we can just do that. Okay, I really didn't think I was going to be fixing my kind of very fundamental coordinate code in this episode, in this stream. Let's just try it. Still not working. Okay, let's keep on looking at this rounding code. So we do a round, we do a round, we do a round. Then we take the difference. That should be a this dot s. No, it has to be an s. believe this code is right. We take the difference between the rounded Q and the original Q. Here they take the difference between the current Q and the rounded Q and the passed in Q. Yep. Here they take the difference between the rounded S. Here's the rounded S. I'm not sure about that negative sign there. That's a bit suspicious. And the passed in S. Yeah, I think that's... so this is now the rounded S, and then we want minus the passed in S. All right, let's be explicit about this. Rounded S. The reason I'm having troubles here is because we do store the Q and the R. I never store the S. So I just need to be fairly explicit about some of this stuff. Rounded S plus the passed in S is that. That should not be rounded. So if you don't define an S, it will go and calculate one for you. Otherwise, it takes the one that you did pass in. It rounds it, and then this does that. Then, when we do the subtraction, I presume this is meant to be the rounded S. Let's take a look. Yes, this is meant to be the rounded S. So let's do that. And that. All right. Let's try that one. Yay, that looks better. Let's see. I've got... from here, we're trying to go from this point to this... Well, from this tile to this tile. And it is telling us to pass through coordinate 1, 0, which is this one over here. Close enough to right. So it'll go from there to there to there. It doesn't matter which of these it chooses. For the sake of testing, I'm going to go from here to here. Oh, well, let's go all the way up to 4, 0. Let's go up to 4, 0. And it should just pass through 1, 0, 2, 0, 3, 0, then 4, 0. 1, 0, 2, 0, 3, 0, 4, 0. Awesome. I'm going to give it another more complicated one now. Let's go from -1, -1 to +2, -1. 1, 2. Where was I? Where did I say I was going to come from? -1, -1. So this time I'm expecting it to go 0, -1, 1, -1, 2, -1. And we get 0, -1, 1, -1, 2, -1. Perfect. That is good enough for me to call that working. So it is now generating that list of hexes. So next what I want to do is I want it to generate a list of yeah, okay, I've got a slight issue here, but I want to generate a list of points in XZ space for it to pass through. Now, the issue I have here is we also need to, we're going to be crossing multiple triangles as we come through these hexagons. Sometimes we'll cross 2 triangles, sometimes we'll cross 3 triangles. Yeah, okay. But for now, I'll just work on getting it to work out which hex tile, get it to calculate where it's going to pass through each hex tile. Okay. Today won't be a hugely long stream, by the way. I do have to head off in about half an hour, so I'm only intending to stream for an hour a day when I do stream, but I have been going a bit longer. I've been quite enjoying it, I've got to say. I do want to thank everyone for joining me. So I'll go another half hour today and then finish up. Um, all right, and I just distracted myself. Path controller, here we go. So let's pull this out into a separate function because I can. And I will call that find hex path. So there's the path through the hexagons. There is one more thing for me to do here, which is I mentioned that this is all using coordinates. So the pathfind options uses coordinates. So these are UVQR coordinates, whereas this is only using QR coordinates. I need to get this to convert back to the chunk coordinates. I think that's easy. I think I just map the hex coordinate to yeah, it's a new coordinate. I think I can take the hex dot divide by chunk. Yes, that will return a chunk coordinate. And then, in fact, it returns two values. It returns the remainder as well. So if I go divide by chunk, that will return local variable. Oh, you don't do that. Const. I think it returns them like that. No. Yes, it returns a quotient and a remainder. I think that is a chunk, comma, axial. So I can just return a new coordinate, which is chunk axial. Now, looking at that same result, it should look exactly the same, but with chunk coordinates of 0, 0 on each of its results. There's our 0, 0. Yeah, we're getting lots of 0, 0s through. But if I give it a more complicated search, like if I go from chunk 1, 1, minus 1, minus 1, so this is off in some other chunk, 2 chunks away. So we're going to get a really long path back here. Oh, that's not fair. Well done. I mustn't be. Oh, yeah, I know what this is. When I pull out the options, so we do that. Origin.qr. Yeah, I need to convert this to the global QR. I thought I had code to do this. I don't. That's unfortunate. Ah, I know how I can do it. My chunk coordinates do have something that lets me go. I can go origin.uv.qr. So that will actually return the global coordinates of a chunk center. And then I can just do plus options.origin.qr. Yeah, this looks, I think this will work. All I'm trying to do is convert these chunk voxel coordinates, so the 4 component hex coordinates, into their global hex coordinates. Don't worry if that doesn't make sense to you. Go and watch my hexagonal tiling episode. I think it's episode 12, 12 or 13. I think it's 12 and 13, if you want a recap of that. Options dot destination QR. But this is something peculiar to me, having these weird hexagon tiles. Let's try that. Probably need to restart the server. Did I even send the right request through? No, I sent the wrong request through. There we go. Has that crashed or just not started yet? Run. Oh, can people on YouTube hear me at the moment? Getting a strange error um, in my chat view saying that something's timed out or something on YouTube. Hold on one moment. I'm just gonna connect myself to YouTube and just make sure that I can see. Oh, it says that it's live. Yeah, okay. I'm not sure what is going on there. It must just be my OBS. Inside OBS, I have my own view of the chat, and it must just be timing out some connection somewhere. Speaking of which, I've just lost my view of the chat. It does, however, mean that I cannot see any of your chat in YouTube, so I'm just going to bring that up. Sorry. Okay, so I've missed a bunch of chat here. Let's quickly go through. Oh, wow, I missed a lot of chat. I'm really sorry about that, guys. The last I got was fun noob codes. The last thing you want is to have your multiplayer game get jittery. Yes, so low spec gaming, JetBrains makes their IDE for web development is WebStorm, but if you have the commercial license for IntelliJ, that it includes most of the IDEs in a single editor, which is IntelliJ. And yes, they do have IDEs for Ubuntu. They're really, really, really good on Linux. Smallest math mistakes in programming, especially game dev, can sometimes have pretty funny consequences. Yeah. Yeah, I agree. That just a little negative somewhere can have pretty big impact. Griffith, Q, R, and S. I might as well give a quick. You may have already worked this out. So this is the coordinate system I'm using. It's a little bit hard to get your head around exactly what Q, R, and S mean. Whenever you move to an adjacent hexagonal tile, it always modifies exactly two of the Q, R, or S components. It's also true that S is always negative the sum of Q and R, or another way of putting it is Q, R, and S always add up to 0. So when we moved from 0, 0, 0 to this tile, we go to +1, -1, 0. So in my code, you'll often see me refer to axes using two coordinates. So let's look at, do I have an axial axes or something? Yes. So whenever I'm moving in a direction, I will move, for example, in the QS direction or the RS direction or the QR direction. And what this really means is if you move in the QS direction, it means increase Q by 1 and decrease S by 1. So this one is leave the R value alone. This one is leave the Q value alone. And this one is leave the S value alone. So it's a pretty strange coordinate system, but it has some really nice properties. For example, from a given point, if you head out by a distance of 1, you will always have the at least one of its coordinate components change by one, and none of them move by two. So if you take the maximum of the change in all of the components, then that tells you how far away you are from your starting point. So this is, you can see that there's a 2 in all of these components, or a -2. So that means that this is a distance 2 from the origin. It has a whole bunch of really nice properties like that. I do recommend checking out Red Blob Games. This website is quite a good little interactive guide for understanding this stuff. Um, uh, yes, so single digit letter variables, I agree, but Q, R, and S are my hex coordinates. UVW are also hex coordinates for me, but at the chunk level. So when I'm moving by chunks, I use a separate coordinate system because everything's rotated by 60 degrees, and so I needed a second coordinate system. I use UVW for that. I also tend to use single digits just for counters and things, or very simple constants. Griffic always implemented hexagons as a grid with every second row offset by a half. Yes, so this site also covers that. That's called the offset coordinate system. What have we got here? Offset coordinates. So this is the coordinate system that you would have used. The maths always works out a lot more complicated with this. You end up with, anytime you're doing processing on your coordinates, you end up with a conditional on whether or not one of your coordinates is odd or even. And so it makes things like distances very difficult to calculate. It makes enumerating hexagons within an area quite difficult to do. So yeah, using the cubic coordinates, I use something in between cubic coordinates and what they call axial coordinates, or what's the other name for this? Oh, there we go, trapezoidal. I use a hybrid of these two. So most of my computations are done as this axial system where you actually just drop the S component. So you'll notice that in my coordinates, I never store the S value here. But because I can always just get it back using the identity that Q plus R plus S equals 0. But so some calculations are easier in this system, some are easier in this system, but they're equivalent to each other anyway. There we go. Yes, so I think we're up to date on the comments. Apologies for that. I don't know why my OBS view has flaked out. I'm seeing the view counts, but not the chats. All right. So where was I? I was trying to get this to work between chunks. Here we go. So I've just gone from chunk 1, 1, which would have a W value of -2 because U plus V plus W always equals 0 in my chunk system. So we are 2 chunks away from the origin, and then within that chunk, it's a point somewhere within 2 points out from the origin again, because this is going to be -1, -1, 2. And we're going to the origin chunk to a point 2, -1, I guess it would be -1 would be the third component. So we get this big long result back. So I now have inter-chunk pathing working, which is good. I'll just check the YouTube comments every now and then. It's a bit distracting for me to have the actual stream on my other screen, so I won't keep it on my screen, but I will check it every now and then now. What do we got here? Okay, so from here, I could actually make a really simple implementation where we don't bother doing the string pulling, because this is a kind of an almost sensible path that the AI could follow. If it just went to the center of each of these voxels, it would do something. It wouldn't be, when you're doing very short distances, it might not be the most sensible thing, because it might turn around, go back to the center of a voxel, and then move along some path before it gets to its final destination. But I'm only supporting, uh, placing mobs. I only place them at the moment at the center of voxels anyway, so it might actually make sense for it to do it like this. The other issue I'm going to have if I don't have a string pulling algorithm is, oops, let's get back to line drawing. Um, it's also going to look a little bit unnatural on a path like this one that I've drawn here, because he's going to walk in a straight line, then he's going to turn by 60 degrees, walk by one tile, turn by another 60 degrees, and continue on his way. But I think this is a pretty good starting point if I implement it like that. So I need to pull up, as a very first point, I need to pull up the y value for each of these coordinates. Now, the terrain service knows these y values because it is able to generate the meshes themselves. Let's see. I need to know which meshes I need back because it's one mesh per chunk. So I need a way of looking them up easily. What can I do here? I can do path dot map. This is a bunch of coordinates. I'm actually going to pull out the chunk coordinate. Is there a unique or something in here? It doesn't matter. I'll do a reduce anyway. And I can test if we've already processed the chunk in my reduce step. So I'm going to do a previous, comma, item. So what I'm doing here is I'm just taking each of these coordinates and loading the actual mesh into, from wherever it happens to be stored. I think I'm only generating them at the moment, but so it's not all that efficient, but this will do. And I'm going to start with an empty array, sorry. Const uv is going to be item dot, well, just item. If not u in prev, so I'm just building up a dictionary from the u and the v coordinates to the mesh. If we don't have the u, then prev u is going to be equal to a new dictionary. It doesn't like that because of the any. Yeah, let's just tell it it's an any. This is all going to change anyway. So we make sure that's populated. Now, if not v in preview, then prev uv is going to be equal to, how do we get the mesh? Get the mesh for a chunk coordinate. There it is. Okay, I think that this will generate a dictionary of the form. We'll be able to do, for example, meshes 0, 1 would look up the mesh for chunk y, u equals 0, v equals 1. So there's our meshes. Then I need to look up the y value. So that's easy enough. We just go path dot map. And in this case, we're going to go const chunk coord is coord dot uv. I don't really need that beyond. Let's just grab the mesh. Const mesh is going to be equal to meshes uv. Oops. Coord dot. Oh, I can't type. uv dot u uv dot v. So we have the mesh. I then need to look up in that mesh. I need to look up the height of a particular point. So our point in this case is const axial is going to be equal to coord dot qr. Now, this is really dodgy, what I'm about to do here. Because the mesh at the moment contains a bunch of vertices, but I don't store any of the QR coordinates for the hexagons that formed them. But I do know that the center of each voxel will exist as a coordinate inside that mesh. So I think I can just say, I'm just going to call it xy is going to be equal to axial dot xz, sorry. So that's the x and the z coordinate. I think there's also a y coordinate in there somewhere, but then all I need to do is say mesh dot vertices dot dot find. Does this take a predicate? Yeah, let's watch me learn JavaScript again. Type script array find predicate. Yeah, good old Stack Overflow. Array.find, and it does. I assume it does exactly what this does. Yeah, okay, so we pass it a predicate. Vertex goes to vertex 0 is equal to xz.x, and vertex, this is really dodgy because I'm just comparing floating point numbers here, and so any rounding is going to break this. So this may well not work because of the rounding. What doesn't it like here? Explicitly has any type, really? Get mesh returns a mesh. Mesh has a vertices, which is of mesh vertex. Oh, do I need to export this? A little bit confused here. Why can't we see mesh vertex? Oh, that's not meant to be a colon. Oh yeah, that's meant to be a colon. Find vertices. Ah, I see the problem. I made this an any, whereas this should actually be a u colon number maps to v colon number maps to mesh. Empty mesh. This is totally wrong, this code in here. This is never returning anything for starters. Yeah, this is a bit dumb. Const empty mesh is going to be equal to, which is itself one of these. Is going to be an empty object. Still doesn't even like that. Ah, I'm missing a brace. Yep, there we go. Then this won't work because we're never returning anything. All right, this is not the way I'd normally do this. I'm just trying to get this to work as quickly as possible. Really shouldn't be doing this stuff in place like I am here. This should be done using a spread operator, but I'm trying to remove duplicates at the same time. I have no idea if this is even going to work. Now, I should be able to find... Here we go. So find that and return it. Const points. So what this is going to do, it's still not generating a valid path, but this will go and take each of the points, which I'm already returning. Where's my... Here. So it'll take each of these points, ignore the y value for now. It will look it up in the mesh, and it will find a vertex in the mesh that matches the x and the z coordinate. Now, it should be doing a close to or something like that at this point, or better yet, it should be finding a triangle containing that vertex, or the closest triangle to containing that vertex, and then calculate a y value. But this might do... Griffith says, yeah, I should be using a spread operator and a set. Yeah, okay. The ip with using a set is I still need to have... So yes, this should be a spread operator replacing all of this. But I only want to do this get mesh if the thing doesn't already exist. All right, I'll clean this up. I don't even need to use a set. I can do it using a plain TypeScript object. I could just check against the height map, but I am about to adapt this code to work to find the actual edges of the triangles that we're going to cross, because the height map only contains a single... I don't have the client open at the moment. The height map only contains a single value per voxel, whereas the voxels get drawn as 6 non-coplanar triangles, or not necessarily coplanar triangles. And I'm trying to get the mob to kind of navigate those little bumps and things within the voxels themselves. So I don't want to use the height map data. I will clean up this code though. The first thing I need to ask is, has this mesh already been loaded? Already been loaded. And that's just saying if prev question mark u question mark b. Is that the right syntax? I probably need some dots somewhere in there. Question mark dot. Is that it? Yes. So if we already have an entry for the u and the v, then just return the previous value. Otherwise, we should be returning the previous value spread out um, with a u value, which is the previous value's u spread out, and a v component, which is get mesh item. Yeah, okay, so that wasn't so bad. I wanted to avoid writing that code, and that's actually simpler than what I had. So yes, thank you for chastising me for being super, super dodgy there. Yeah, lerping between neighboring voxel heights is going to get pretty close to right. But I kind of want to avoid um, um, what will happen is if you've got a voxel that is on a big slope and then a voxel next to it that is flat, you'll end up with the mob kind of hovering, or round the other way, it could end up just passing through the ground, its feet passing through the ground, and that's what I'm trying to avoid here. It's where there's a rapid change in terrain gradient. I don't want the mobs clipping the terrain uh, or levitating, and that will happen if we lerp. It'll get worse if I increase the size of my voxels. I still haven't decided how big I want my voxels to be. If I increase the size, then it'll lead to kind of bigger angles potentially. And yeah, so that's what I want to avoid. Okay, that kind of looks okay. Yes, that's correct for cliffs and stuff. But even without cliffs, you still get some decent size angles. If you've got like a 30-degree gradient, and then the voxel next to it has no gradient, then you could you will see some levitation there. Um, okay, does it at least run? Let me just restart the server. I have no idea what state the server's in. All right. Um, this still isn't quite right. The issue here is that these coordinates are chunk relative coordinates. So this is the X and Z coordinate within the chunk. But this should obviously be returning a global coordinate of some sort. Yeah, I'll see if I've got time to show you, Griffith, what I mean there. The gradients actually change across voxels in the way that I've implemented them. Um, uh, yeah, I'll see if I can show that in just a second. In fact, I might be able to do it now. There's no reason I can't run the client now. Uh, so you'll notice that you can't actually see that which triangles form which hexagons here. And the reason is, if assume that is the center of a voxel. Oh, well, I know it's not. I happen to know that this is the center of a voxel because this is a sand voxel. This is the center of a voxel, and you'll notice that the gradient isn't necessarily consistent right across the voxel. That's because it does perturb both these corners and the center. It perturbs up and down a bit based on its neighbors. So if I were to just use the heights, what just happened there? I just clicked something. If I were to go from, say, this center here to this center over here, you can see that a mob would pass through those. Question for voxel A bordering on B, pointing A, same gradient. Yeah, so I do a lot of smoothing in here. Well, not really smoothing, but yeah, I perturb these points up and down to minimize well, to remove any steppiness between the voxels. So I'm intentionally not doing the Minecraft thing of having flat, then cliff, then flat, then cliff. And the voxels themselves don't have an intrinsic gradient. The gradient comes from the fact that their neighbors happen to be higher or lower. Okay, now this here, so these are chunk relative coordinates. So I also need to apply the X and the Y for the chunk. That's really easy to do. So const, let's go chunk relative is going to be equal to that. And that's, I'm going to return the coord.uv.xz plus chunk relative. That doesn't look right. What's wrong there? Ah, yes, that's because this is just an array. It's just like an array of 3 values. So I'm going to do a new vector3 chunk relative.x, comma, chunk relative.y, chunk relative.z. Yes, I will have a physics engine. I could do it using raycasting. I think I'll have a physics engine. Again, one of the issues is I need even anything that uses a physics engine. I need to be I need it to be stateless. But regardless, I still need to find the points of inflection. So I need to work out where I need to find waypoints which cross those triangular, if something's trying to wayfind down through here, I know that there's a point of inflection here. I know there's a point of inflection there. So I kind of need to find those points anyway. So for the purpose of pathfinding, I don't want to do it using raycasting because I still need to know what the X and the Z coordinates of those crossing points are. Yeah, the lack of state is a real pain. And people have suggested that's where I'm going to get very, very frustrated, but we will see. Why is that not working? Chunk relative, that's not .x, that's meant to be a 0. That's meant to be a 1, and that is meant to be a 2. It's still not working. Yeah. Yep. I mean, I'm tempted to be super, super, super dodgy here. This is obviously all going to change anyway. I will put a comment in. So obviously what I really want to be doing when I'm doing this pathfinding, I won't be using vertices from the center. I'll be finding intersection points from the triangles that make up the mesh. Yeah, I have a feeling that to do physics server side, I'm going to have to do my own engine and have it work, have it take advantage of the fact that everything can be kind of chunked and have it pre-compute data in a form that's easier to serialize. It's a combination of easy to serialize and easier to perform calculations on. So it will be able to kind of pre-compute the models for a chunk at a time and just go from there. But yeah, out of this box, I don't think I'll be able to use a physics engine necessarily, unless I have a kind of a physics microservice that is able to delegate work based on which chunks are loaded into which instances. That's another option. Yeah, I don't mind kind of the computational geometry stuff. So, and it is a subset of physics that I'll be doing. I'm not going to do I might do obviously mesh collisions of convex hulls and things, but I don't need to worry about, I'm not going to be computing how fast something bounces off in a collision, for example. So, um, I'm not too concerned about writing a physics engine because I don't mind doing mesh collisions. That's something I'm comfortable with. The question of are two meshes colliding, two convex hulls colliding, I'm comfortable with. And as long as I don't need to do any more than that, then things will be fine. All right, I do need to finish up pretty soon. All right. I think that this will kind of work. Do my values make sense? So my first value here is in a chunk far, far away. And my first point here is, that looks much better. We're off way outside the radius of a chunk. So I reckon this is generating a path. So if I get more time today, I will look at getting the troll. I probably won't get around to getting it to follow this path, but I might look at putting a component on a troll, having the ability to put a component onto a troll at runtime that will cause it to call into this code and fetch the path that it's going to follow. Because my suspicion at this point is that following through these points will get pretty close to what I want. It will clip the terrain a little bit and float a little bit in those when there are steep inflection points. But coming down a smooth bit like this, it should be absolutely fine. It's only when it's doing stuff like this that it might clip the terrain a bit. And then hopefully I'll definitely be able to stream tomorrow. I might do a slightly longer stream tomorrow. I will hopefully get that troll actually working. Does it have full atmosphere simulation stuff? Yes. Anything to do with velocities, that's where my conservation of energy calculations, that I would not be comfortable doing, and calculating how colliding bodies will rotate as they bounce off each other. I'm not all that comfortable with that kind of stuff, but hopefully I won't need that. Thank you everyone for joining me. I'll stream again tomorrow. If you haven't watched the episode yet, be sure to check it out. The weekend's devlog episode. And I'll see you all tomorrow if you can make it. Thank you very much. Catch you around.